All right. So we've had conversations about how to express a number and identify the, and in that expression, identify the number of significant digits or the number of, or the amount of inaccuracy within that measurement, right? And so here is a scale of some sort, and it's measuring something for us. And we're going to look at this and try to identify what the resulting value should be. Okay? So, how much of this red stuff do I have here, Fred?
Does it look like 21 and a half?
Okay? Is it 21.5 or is it 21.4 or 21.3 or is it just 21? Should I maybe just put down 21 because I don't know how much of the rest there is?
You said in the previous video that we can write down our own estimate, right?
That's right. Our estimate can be one of the values that we write down.
So this would be like 21 point something.
That's right. 21 point something. And maybe, I don't know, what do you think? What is it, Fred?
I think it looks like 21.4.
All right, 21.4. That's a reasonable number. That value expresses our, and we'll put in here milliliters for now because we don't like to see numbers without units. But that value, this number here, tells us that the 21 we're confident about, the last number here we're not so confident about, but it's either one higher or one lower. Hopefully, we're not expressing it not too far off, right?
Okay, sounds good.
Now, what if I got a better scale? This scale goes and expands my range between 21 and 21, or 21 and 22. All right. If I look at this one, I have 21 here. And this is 21.1, 2, 3, 4, 5, 6, 7, 8, 21.9, and then 22. Right? So what value can I write down there?
I guess you can write 21.3.
21.3, how can you tell?
Well, because we can see it's not quite 21.4.
All right. Is if I write down this 21.3, is that 3 an estimate?
Yeah.
It's not an estimate though, isn't it? Because I know it's above the 3. I can see it above the 3.
Oh, yeah, okay. So our estimate would be like 21.3 with an estimate of maybe 3 or something?
Very good. So our estimate would be something in there, maybe 21.2, 21.1, something like that. But now we see that we have more significant digits, 4 of them, as opposed to 3. So if our device has the ability to measure more significant digits, we can express that by writing that. And that's what you need to be able to do. You need to be able to look at a measuring device and identify the number of significant digits that should be written down. All right, now we talked about this as well. Sometimes numbers aren't measurements, but they're expressions of exact values. So for example, a dozen eggs isn't maybe 12, maybe 13 sometimes. It's an exact value, so it's always 12. A dozen is 12. All right, so which of these is a reasonable answer for this, the volume in this container?
The answer is,
Wait. Let them give a chance to answer the question, okay? So you go ahead and push pause, answer the question, then we'll see if we got it. All right, Fred, they're ready. Give it to them.
I'd say 7.4.
7.4,
Oh, no, 7.3, sorry.
7.3.
Wait a second. Why is there 7.3 on there?
Well, maybe it's a mistake. Maybe it's not the right answer. What do you think?
Oh, I guess we need one estimate, right? So 7.3 something would be our estimate. So I guess C would be the answer.
That's right. So 7, 1, 2, 3, not quite to 4, and then we include the estimate. So we know it's 7.3 and then 7.35. So 7.35 then would be a reasonable answer. 7.4 would not be reasonable. This expression is indicating that the 4 is an estimate. But in this case, we know that it's 7.3, it's not 7.4, so that's not where we would want to express our estimate. Okay? All right, how about this one? You got it?
Yeah, I got it.
All right, what is it?
It's the same thing, 7.35.
Okay, I did something here. I tricked you, didn't I?
What do you mean?
Well, see, sometimes values are not going from the bottom to the top, but they're going from the top to the bottom. For example, in a burette or a pipette, you're trying to identify how much water you've delivered starting from zero, and so your numbers will be increasing as you go down.
Oh, there's not an 8 up there.
That's right. So it's going from 6 to 7. So here you have to go 6.1, 2, and then identify the reasonable answer that way. Okay, so everybody at home, let's see if you guys can get that answer now. Work on it. All right, hopefully you had a chance to work on it and get the right answer. Give it to us, Fred. What is it?
6.6 something. Is anyone like? Oh, C.
That's right. 6.62 will be our answer here because this is 6.5. We know 6.6. And what is the 0.2, Fred?
That's our estimate.
Very good. Excellent. All right. So if we just see a number, we need to have the ability to identify how many significant digits are in that number. And that's pretty straightforward. If you see a number like this or this, you can just count up all the values. But it becomes trickier when there are zeros involved. If the zeros are in between significant digits, they're significant, right? How many of these values in the scenario 2.0056, how many of these values are an estimate, Fred?
Just the last one's the estimate.
That's right. So the 2, the 0, and the 5 were something that the person who was making the measurement knew because of the device that they were using. But this 6 was an estimate. Now, what about this sort of a scenario where we're ending in 0? Well, we use a decimal point to identify the number of significant digits. So this has 4 and this has 2. We can use the decimal point like that to help us identify the number of significant digits. In this type of scenario, there was no measurement, no material, nothing there to make a measurement in the tenths, the hundredths, and the thousandths place. Only something in the 10,000ths place gave us one significant digit, therefore. Here, we had something here and something there, and this was our estimate, so there's 2 significant digits. Or in other words, zeros to the left of the first non-zero digit are never counted as significant because there's nothing there. All right. At the end, if we don't have a decimal place, we can't assume that they are significant. So if it just says 20 or 300 or 10,000, right? How many significant digits are there in the number 10,000, Fred?
Well, I guess that's just one. Is that what you're saying?
That's right, just one significant digit. If I wanted to express that this was supposed to be 5 significant digits, I could throw in a decimal place, right? Another way to express the number of significant digits would be to use scientific notation. 1.0 times 10 to the what? If I want to express 10,000 in scientific notation, it would be 1.0 times 10 to the what?
How do you do scientific notation again?
Well, it takes the number between 1 and 10, and then we multiply it by 10 to some value to get whatever value we're after. So if I 1.0 times 10 to the, in this case, it's going to be 1, 2, 3, 4, right? Because I moved the decimal place over 4 times to go from my 1 to my 10,000. All right, 1 times 10 to the 4, that's this expressed in scientific notation. And then I can use the number there to identify how many significant digits. How many significant digits must be in that expression right there?
Are zeros after the decimal place significant?
They are significant. Yes, they are significant.
So that's 2.
That's right. That's right. And if I wanted to express this as 3 significant digits, I could go 1.00 times 10 to the 4th. They're the same value, but now this one is showing that I have 3 significant digits. This one is showing I have 2. All right. This one is showing I have how many significant digits again?
Without the decimal place, 1.
That's right. And with it?
The 5.
That's right. Very good. Excellent job. All right. So how many significant digits here?
That one's easy. That's 3.
Very good. How about this one?
You said zeros after are significant, right?
That's right. Zeros after the decimal place are significant.
And zeros in between significant are significant.
Yeah, that's right.
So that means there's 4?
That's right. There's 4 significant digits. This is significant if it's after. If it's at the end one, somebody's placed that 0 to tell us that the last estimate was 0. And this is a significant digit, therefore they're all significant. How about this one?
That's just what we did. This is only, it's only,
Wait, don't tell them yet. Let them use a second to identify or try to figure it out themselves. Okay, hopefully you took a second to figure it out. Tell them, Fred.
that's just 1.
That's right, just one significant digit. All right, and this number here,
Oh, that's tricky.
let's give them a second to try to do it themselves. All right, Fred, how many?
I'm gonna go with 3.
Very good. Excellent job. 3 significant digits. Fabulous. That's the 5 and these 2 zeros right here. This is not significant. There's no number, there's no amount of measurement there to be significant. This is our last estimate, right? So our estimate is the last significant digit, so all 3 of them are significant. All right. Here's a couple more practices.
I'm ready.
Okay, make sure you're ready at home. Push pause if you need to. What's the answer, Fred?
That's 6. Wait, no. Oh, it must be 5.
That's right, 5 significant digits. That 0 is just there to confuse us, right?
Okay, that's dumb.
All right,